Hello, my name is Lachlan Toth and this is my Microfood Farms project for the Self-Sufficient Living Studio. My main project for this studio began when a friend of mine, Lewis, came to me with a potential project for his business, Microfood Farms. Due to demand, the microfood farm business is expanding and Lewis is aiming to build a farm with technological integration so that the whole hydroponic system can be automated. With the help of Lewis's friend and robotics engineer James, we aim to build a full hydroponic setup for him. Some of the main automated systems that we hope to achieve out of this project is a fully controlled watering system and lighting system, whilst also making it a lot bigger than what he already has. So at the moment, as you can see there, his setup holds 12 trays and we hope to get at least 24 planter trays. Some other smaller things that we hope to achieve out of this system is a full air circulation and humidity regulator, as well as potentially energy regulation and potentially harvesting. With the help of James, our robotics engineer, we hope to integrate a Raspberry Pi into the system to control all of these technological parts. So microfoods, or superfoods in other words, get their name because they hold up to 40% more vitamins, minerals and antioxidants than standard vegetables grown to their fully mature state. These plants are just your regular vegetables such as sunflowers, radishes and amaranths. And they're actually just the same plant, but they're harvested at the cotyledon stage, which is about 7 to 10 days after they're planted. And the system is fully hydroponically grown, so that means no bacteria or pesticides or chemicals. As you can see here, Lewis actually lent me some microgreens to grow myself, so you can see the planter trays there and how I've watered them. As we delve into the project, there was a few other areas that we wanted to address. One of them being the sterilization of the substrate. So in my research, we looked into a few different ways we could do this. One of the ways was steaming the substrate before being put to use. As we looked into it more, we kind of decided that the project was probably not going to help the situation as much because we could just get substrate that was already sterilized. So we looked into other things instead. Another smaller project that we wanted to look at was actually the cleaning of the trays. So this actually takes up to 5 hours a week for Lewis to clean all the trays, and he has to clean up to 100 trays a week plus. So we looked at mounting a standard pressure washer and moving it along a linear actuator that would be able to clean the trays. The only problem was that it would still need labour and the labour of Lewis, which would almost make the project irrelevant. This is something that we put on hold for the moment because we wouldn't be able to do it within the 14-week period. So we looked mainly at the full hydroponic setup and the system itself. This is one of my first concepts for the hydroponic system. So in the details, you can see that we have a watering system that would go through and water the 4 levels individually. So you can have different microgreens on each level. The water is controlled. The water pH is controlled through a series of different parasaltic pumps that'll bring the pH up or down. You can see the CPU box there, which will house the Raspberry Pi and control everything around it. You have an exhaust fan on the top of the tent to regulate the airflow in the hydroponic system. You can also see with this system that the water flow will actually be brought to the front of each tray, and through gravity it'll run past all the planter boxes before going down and back into the main watering system. This is another concept which I designed with a bit more of a creative side that explored a bit more of the preliminary research I conducted that was inspired to mimic nature. So you can see the water flow on each cylinder actually kind of mimics the the geometry of a shell. However, when we looked into how we were going to make this, we realized that it was actually going to be quite hard and very difficult to make, which also meant that the expenses were going to be a lot more, meaning that the first concept was actually a lot better and what we were going to go with, as this is basically a budget-driven project. When I was looking into the irrigation system and how it was going to work, I decided to make a prototype of it all. After a trip to Bunnings, I got some PVC pipe together with some fittings to resemble the main frame. And then I used a series of pipes and solenoids to direct the water flow evenly. It was quite interesting because I had this pump that pumped water through from a main body of water into the system, and I had to adjust all the solenoids to get an even flow of water. We originally wanted to incorporate the trays that Lewis already has. You can see there a 3D scan of one of the trays, just using recap. But we decided that it was going to be quite difficult to get a proper water flow through the whole system, so I began modeling my own tray on CAD. Now this main tray would be able to house up to 9 tray inserts in the whole system. So it was quite great because we could actually use the same tray inserts that he already has and have the water flow through all of them evenly. So this main frame could be constructed from wood and then lined with a pond tray so that it can actually be fully waterproof. This is just a little 3D print that I did of the tray and all the tray inserts inside it. Now that I had the tray design done, I looked at how I could design the main frame. I looked at PVC pipes and other metals to try and get the best price and value for structural strength. So eventually I decided to go with square bar steel because it's very strong and it's actually quite cheap when it comes around to it. So I designed this main frame so that it could have 4 levels and the lights could be mounted on top of each level. And after doing a full price workout, I priced the main structure out to be $260, which is actually quite cheap compared to something, for example, the PVC pipe structure that I put together, which actually cost up to $700. So here you can see how the trays and the main frame interact. Having a closer look at the trays, you can see I have an inlet from one side and there's a smaller diameter of the piping compared to the outlet on the other side, which means that it's very unlikely to overflow. And we have an overflow setting at a certain height, which allows each trays to individually get filled up and be submerged by about 5 mil before the water will start pouring out and back into the main watering system. You can see the tabs of each tray actually help the tray inserts to sit above the bottom to allow water to flow through the whole 9 trays evenly. Here are some renders of the final design. In this render, you can actually see the water outlets. So the higher one will be the water flow when all the trays are filled up evenly, it'll start to pour out that way. The lower one is actually almost like a fail-safe to if need be, the trays to be all the water in the trays to be flowed out completely, to leave it dry and to avoid having algae and other bacteria developing. Looking into the technological integration, I had a look at all the components, the electrical components that would be needed for the system. So obviously run by a Raspberry Pi, we would also need things like a water pump, a flow rate sensor, a float sensor, some water temperature sensors, an exhaust fan with also fans on each level to get the air flowing through the plants. We would also want a humidity sensor, vapor pressure deficit sensor, and a CO2 sensor. These would all be connected to a main fan that would sit at the top of the system. For the power consumption, we would be able to monitor it using a split transformer and an analog to digital converter. We would also have an LCD display to display all all the different parts and what's going on and what the sensors are sensing from the outside of the tent. We would also want to incorporate a time-lapse camera to capture how the plants are growing and to be able to be monetized from afar. To control the water, the pH in the water, we're using a series of parasitic pumps and a pH sensor and electrical conductivity sensor that would measure the pH in the system and control the parasitic pumps accordingly. So here you can see I've mapped out where we can find all these different components and how much the whole thing put together would cost. So all the components that you see around the main frame would all be integrated into the system. The water tank would be mounted underneath, the parasitic pumps would be mounted on the side, and this would all work together accordingly. And for the total price, I worked it out to be around $2,500 for the system. We did want to get a final product done and finished, but unfortunately, because all the other side projects that we kind of got carried away with, this is the best that we could do. At least get a pricing done and where we can find all these components. So the next thing from now on is for James, our robotics engineer, to get the whole system working with these electrical components and put it all together. So yeah, that's it guys. I hope you liked my presentation and have a nice day.